Imagine you're trying to predict something, like a person's salary. You might think salary depends on experience, but it also depends on education, age, job level, location, and even industry. When multiple factors influence an outcome, we can't look at just one thing in isolation. That's where multiple regression comes in. It helps us figure out how several things work together to affect one main result. Let's break it down step by step, with clear logic. Multiple regression is a smart way to see relationships between one main thing you care about, like salary, and several other things that might influence it. Think of it like cooking. The final dish, a cake, is your outcome. The ingredients like flour, sugar, and eggs are your independent factors. Multiple regression helps you figure out how much each ingredient matters and how they combine to make the final result. For example, it can tell you how much experience contributes to salary, how much education adds, or how much age matters after considering experience and education. It's a way of saying, if I keep everything else the same, what happens when I change just one factor? Let's say you work for an HR department and want to know what drives employees' salaries. You collect data on experience, education, age, and projects completed. You feed this information into a regression model. It might show experience is the most important factor, with education adding value, but age less, so once experience is included. Projects completed are a strong secondary factor. This provides evidence-based insights into what truly influences salary, instead of guessing. Multiple regression is used everywhere because most things in life are affected by more than one variable. In business, it predicts sales using advertising, price, and competition. In healthcare, it understands how diet, exercise, and sleep affect blood pressure. In real estate, it estimates house prices using size, location, and rooms. It's like detective work, separating real causes from random noise. Think of it as a super smart line that passes through your data points, learning patterns and finding the best balance between all factors. For example, if you give it new information like a 30-year-old with 5 years of experience and a master's degree, the model can estimate that person's likely salary. A big advantage of multiple regression is that it allows you to control for other variables. Suppose older people earn more, but also have more experience. Is age or experience the real driver? Multiple regression helps you figure that out. It tells you if age still matters after accounting for experience. If experience has a big effect and age doesn't once controlled for, then experience, not age, is the real driver. When you run a multiple regression, you get 3 main pieces of information: direction, strength, and fit. Direction tells you whether each factor pushes the outcome up or down. Strength shows how strongly each factor influences the result. Fit explains how well all your factors together explain the outcome. This turns vague relationships into measurable insights. Imagine driving a car, where speed depends on the gas pedal, road slope, and car weight. Multiple regression is like a dashboard telling you exactly how much each factor affects your speed. You can then predict your speed in any situation. While powerful, it's easy to misuse. Correlation isn't causation. Too many variables can make the model confusing or unstable. Overfitting happens when the model learns random noise instead of true patterns. Highly related factors, like age and experience, can mess with accuracy. That's called multicollinearity. The key is to choose meaningful variables, use enough data, and interpret results with common sense. In plain terms, it's a tool for prediction, explanation, and decision-making. A business owner could use it to invest in advertising, a doctor to understand patient recovery, or a student to improve grades. Multiple regression is a method for understanding complex relationships, looking at many factors together to figure out each one's contribution to an outcome. It helps answer, which factors matter most? By how much? What happens if I change one thing? It turns data into understanding. In short, multiple regression means many influences, one outcome, and clear insights. It's how data scientists, economists, and researchers make sense of a complicated world, one variable at a time, all at once.